So in this case, we need to have a basic view of our trigonometric equations. That's another part, which is actually the last part of your trigonometric equations, of your trigonometry, I mean, working with the trigonometric equations. If we are to consider to say the sine or maybe the cos of a certain angle is equal to, let's just say 0.5. An equation you're supposed to solve for what is unknown. And what is unknown is the angle theta. If we are to go back to our basics of our trigonometry, because these expressions is not the first time that we are working with them. All right. Remember back then we were simplifying this. I want us to have our calculator in degrees. All right, that's number 3 there. All right. You were simplifying sine 30 degrees. This is what? The angle, 30 degrees. Here, it is our angle, this one. You were simplifying this to get an answer, which is what? 1/2 or what? 0.5. So now we are saying, what is this angle that gives us the answer of 0.5? This is what we have, the angle, which gives us 0.5. So as you can see, our answer was supposed to be what? 30 degrees, sine of 30 degrees. It gives us 0.5. But it is not only that, because if we were to take this into consideration, let us say we put that again, we have 150 degrees here. We put 150 like this. I want you to see. Same answer again, 0.5. So under a trigonometry or under trigonometric equations, we do not have one answer that we say this is our only answer. So whenever you are to solve trigonometric equations, you must be given an interval. You must work with an interval. You work with the given interval. Because there are so many angles that can give us that answer that we are seeing. So you work with the given interval. There are so many angles. So the interval that we are given, because it can be a condition that, let's say we had the same angle that we had simplified of 30 degrees. Let's say it was sine of 390 degrees. What was going to happen? I want us to, we'll go back there. Sine of 390 degrees. We are getting the same answer again. 390 degrees is more than 360. We know our interval depends with what you're given from where to where. There are so many, they do not end answers which can give us what? 0.5, because the graph of a sine is a continuous function that does not end like this. So where we have 0.5, it won't end. So that's why we must have an interval. Is it theta is greater than or equal to 0 degrees, less than or equal to 180? Is it theta is greater than or equal to 0, less than or equal to 360 degrees? Are you working with the negative angles, negative 360 degrees up to 360? Remember, we talked of negative angles, so you must also be able to relate to those. So the question is, how do we find the theta that we have been seeing here, 390, the 150, the 30 degrees? How do we find that angle? So what you're going to do, one, is to find the exact value of the angle. You are supposed to determine the reference angle first. You determine the reference angle first. So the reference angle is the acute angle which is given on the trigonometric function that you are given. Like in our case, we are given the sine of theta. So the sine of theta is equal to 0,5. As you can see, it's a positive. So even if it was a negative, you ignore that one. Just, okay, sine of theta is 0,5. So our reference angle in our case is equal to what? It will be the inverse of the sine on the other side, or arc sine on the other side. So to get rid of this sign, to remove this sign, it's arc. You place an arc here, arc sine, inverse of sine. So you must also have what? The inverse of sine here. So that is, we have the reference angle. So if there was a negative, you ignore that. The negative is going to be determined on the quadrants. So that's our reference angle, this one, which is an acute angle that you're going to get there. You're going to get an acute angle. So this is what we have. Arc sine, which is shift sine like this, arc sine, as you can see, -1 of 0,5 as it is. This is going to give us 30 degrees. So this is what we have, 30 degrees. But we are saying that 30 degrees is the reference angle. It is not the exact angle. So for you to have the exact angle, which is the theta that we are given there, that's where the interval plays a role. You must be given an interval to say your theta must be taken from where to where. So let us use the interval for theta is greater than or equal to 0 degrees, but less than or equal to 360 degrees. So this is it. You have the reference angle. You are going to each quadrant and figure out where a sine of theta, the one that we are given on our original question as 0,5, where is it that it is what? A positive. As you can see, it is positive. Remember from our quadrants, the cast concept. All right? Sine, where is it positive? It is positive here for all. And here where we have got S here, sine is positive. In these two quadrants, it is negative. We were going to use these quadrants if it was a negative, but this one is a positive. So how do we take our answers? From the reference angle. Remember I talked about these guys when you're using those angles from our reduction. We're saying this is theta, this is 180 minus theta. But now we are talking of what? The reference angle. So the first quadrant, it is the one that carries the reference angle here. So our theta will be equal to the reference angle. Here, we're going to have the reference angle on this part. So our theta is going to be 180 degrees minus the reference angle in the second quadrant. In the third quadrant, the reference angle is going to be here. So our theta is going to be 180 degrees plus the reference angle. If it lies in the fourth quadrant, this is where you have your reference angle. So your theta is going to be 360 degrees minus the reference angle. These are the conditions that you must work with. In which quadrant does that sign lie? It is a positive in the first and in the second. So our solutions must be taken from the first and second. So from the first quadrant, what will be our answer? From the first quadrant, our exact solution now for theta, the one that you're given here, is equal to what? As we can see in the first quadrant, theta is equal to the reference angle. So it means the reference angle that we obtained is part of our answer. Theta is equal to 30 degrees. That is the condition there. You do the same thing because sine is positive in the second. So for the second quadrant, what are we going to have? So for the second quadrant, our answer, which is the exact angle that we need, that we are asked to calculate, is equal to 180 degrees minus the reference angle. So that's theta is equal to 180 degrees minus our reference angle is what? 30 degrees, just like that. So you're going to have the value of theta, which is 150 degrees. So in this interval from 0 to 360 degrees, from 0 to 360 in this quadrant concept, that is where sine is positive in the first and in the second. So therefore, these are the solutions that we have in the first quadrant. So therefore, theta is equal to what? 30 degrees, or theta is equal to what? 150 degrees. For the interval that we are given for theta is equal to theta is greater than or equal to 0, but less than or equal to 360 degrees. For that interval, we could have been talking of other answers which are different from this if the interval was changed. So you work with what you're given. From 0 to 360, that's it. Remember, this is our quadrant from 0 to 360. So normally that is what you're given. They can say from 0 to 180, 0 to 360 mostly. That is the condition. You must have the reference angle first. Then you consider that reference angle now in finding of the exact angle, which is your theta, or it can be x. Whatever presentation that you're given, you use the way that you are given on the question that you'll be given. So that is how these questions are given, as you just need to make sure that you work out as many questions as you can, but you must have the reference angle. Then from there, you use that reference angle to determine or to work out the given solutions. All right, so for the same interval from 0 to 360 degrees, let's say we're being asked to solve with the same concept. It is not always where these questions, they are direct. Sometimes we must use the concept of our trigonometric, remember, those trigonometric identities. All right, let's say we're given 2 sine of x is equal to cosec of x. From 0 to 360 degrees, we want to find the values of x, which is the exact value that we need. So as you can see, cosec can be changed. Cosec, this is 2 sine of x, which is equal to cosec. Remember, it's same as 1 over sine. So this is 1 over sine of x. So we can cross multiply. Let's see what is it going to look like. If we cross multiply here, it is going to be 2 sine x times sine x, which is 2 sine squared of x, which is equal to 1 times 1, which is 1. That's equal to 0. All right. Which is equal to 1 times 1, which is 1, like this. So that is, we have cross multiplied. So that's a quadratic. As we can see, highest power is what? Is 2. So can we factorize this? Is there an identity that we can use? It's going to be difficult. But remember, if we are given back to our algebra, x squared is equal to 4, we can find the square root to square root. So x will be equal to plus or minus 2. So it's the same thing. There's a squared there. And sine is a single term. So let's make that one the subject. Simply divide by 2. So it means the sine squared of x is equal to what? It is equal to 1 over 2. So we can have the sine of x by getting rid of the square. How do we get rid of the square? We introduce the square root both sides. Knowing that this will neutralize, we have the sine of x, just like square root, and this we've got x. And we know that the square root of any number is what? Plus or minus. So you're going to have plus or minus the square root of 1 over 2. The square root of 1 over 2, like that. This is our sine x. So as we can see, there are 2 answers there. There is a sine of x, which is plus the square root of 1 over 2, or there is a sine of x, which is equal to negative square root of 1 over 2. So as you can see, one is positive, another one is negative. So for both conditions, whether it was a negative, whether it was a positive, you were going to have or to determine the reference angle. That part is not going to change. Just like our previous case, we're going to have the reference angle, which is the inverse of the sine or the cos, whatever that you're given. Here we're dealing with a sine. So it is going to be arc sine. So that's arc sine, the inverse of a sine. Arc sine of what? So it is arc sine of this part that you're given. Ignore the sign. It's a positive, it's a negative. Ignore that part. Just write value that you see. So that's the square root of what? 1 over 2. Arc sine of this. So what were we going to have? That's our reference angle. So we need arc sine, shift sine, the square root of 1 over 2. So that was going to give us what? All right, let's move aside and close the bracket. That was going to give us 45 degrees. That's our reference angle, the acute angle that is affecting our crescent. 45 degrees. So let's start when our sign is positive. Remember from the cast concept, the part that I just explained from our cast concept. Where is it that sign is positive? For positive. Sign is positive where? In the first and in the second. Remember how you present your answers. I just hope I did not erase that part, all right, of our values. Okay, maybe I erased it, no problem, but still fine. Remember in the first we say theta is equal to, but here we're dealing with what? X. So X is equal to the reference angle. Here X is equal to 180 degrees minus the reference angle. Here X is equal to 180 degrees plus the reference angle. Here our X is equal to 360 degrees minus the reference angle. Remember that concept is not going to change. So we are dealing with a condition where it is a positive first here, where it is a positive. So like I said, in the first here and in the what? In the second. That is where our sign is positive. Where it is what? Positive. So it was going to follow that X is equal to what? Where it is positive in the first quadrant, it is equal to the reference angle. So therefore, X is equal to our reference angle is what? 45 degrees. That is it. Or X is equal to what? In the second quadrant, where in the second quadrant, X is equal to 180 degrees minus the reference angle. It means it was going to be 180 degrees minus, what is our reference angle? It is 45 degrees. So we need the difference there. 180 minus 45, which is what? 135 degrees. So these are the conditions for a sign which is positive, this one. It is positive in where? The first and the second. But remember, there are two possible solutions for our sign because there's another one which is negative here. So for negative now, what is going to happen for negative? When this sign is a negative, it means our solutions are the ones that will change. Where are we taking them? That's the only part. Where is sign a negative? In which quadrant? In the fourth quadrant, sign is negative. In the third quadrant, sign is negative. We don't have a sign there, so it is negative. So therefore, our solutions were going to be what? Where it is negative in the third quadrant, X is equal to what? 180 degrees minus, plus the reference angle. So we're going to add. So it's going to be 180 degrees plus, what is our reference angle? 45 degrees. The same reference angle. We are using the same, it was the same from the same thing. The only part that was, it is negative and another one, it is positive. That is the only part that is affecting our question. So for negative, this was going to be 225 degrees. We do the same thing. Another solution where this sign is negative is where? In the fourth quadrant. Because that is for cos. So sign is there is what? Negative. So in the fourth quadrant, X is equal to what? 360 degrees minus the reference angle. So you're going to subtract the reference angle this time. As long you know these, you're done. You're done there. It's going to be like that each and every question. So this is how we simply attempt this typical question. So this was going to give us 315 degrees. So as we can see, there are two possible solutions there for negative. Here, there were two answers in the interval from 0 to 360. Like I said, here, did I mention that? All right, I'm going to use 0 to 360, guys, if I do not mention. All right, we're going to use this from 0 to 360. So there are two answers. Where a sign was positive, we got two answers there where a sign was positive here. So therefore, x is equal to what? Because there are two. Here we also got two answers. So we're just going to write them in order, starting with the smaller one. So these are the answers. Here we've got 45. That's the smaller value. So it's going to be 45 degrees. Or you can have it even as a solution set to say x is equal to, all right, no problem. Or you can just list them. 45, 135, followed by what? 225, and also 315. These are the possible values of x that we are going to have for the interval that we are given. We combine, we worked with a positive condition here. There are two answers. For a negative condition, there are two answers, but they must be combined together and say these are our x values. So do revise as many questions as you can as you are preparing yourselves for the exams which are ahead of time.